Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're gonna talk about Vikram 3201 processor, 32-bit microcontroller. So let's dive deep into it. So what exactly is the need for India to invest in something like this? Well, India's economy is growing exponentially and it is growing in every front. Now, you may be like, okay, India has this problem and all. No, we are a growing economy. Most Western country had the luxury of crossing that without cameras, so they do not have that ugly part of it. Or like people forgot that how ugly London used to be, like how much poop London used to have. It's like there was a time before London's wage system. Not pleasant. So fundamentally speaking, India's economy is growing. However, we have ludicrously high dependency in all core technologies. Meaning, does India make pharmaceuticals? Of course, like bonkers amount of pharmaceutical. Like there are people who are making pharmaceutical, and then there is India. It's almost like spices. Like then there is whole planet making spices, and there is India is like, you guys are doing something. Like it's not comparable. So, isn't that awesome? Actually, no, simply because while we do have machines, we can even assemble machines, make machines, metal parts, cool, everything. The moment it comes to microprocessor, it's like, yep, either call up China or Taiwan or something like that. So that creates an issue. And that goes all the way to the supply chain. It's not just like, okay, no, everything. Be it ISRO, be it Army, be it DRDO, all of them need silicon to compete in 21st century. And all of that is coming from abroad. So that is unwise. And we have been noticing this and we have been slowly chipping away at it. And our first achievement was Shakti processor. It was like a few years ago. It was from IIT Madras, Indian Institute of Technology. Now, IIT Madras branch did this. So, philosophy behind this was there is a new architecture in town, like how you have x86 from Intel, how you have ARMS from ARM Holdings, and RISC-V is an open source. It's the only open source one. So they're like, okay, we take that. And people are starting to develop their own physical chip. Like that's a set of rule book, set of instruction, and you can make the silicon out of it. So somebody has to make the silicon. So this IIT Madras built the basically design and all that, and we designed the processor. But here's the deal: who manufactured it? It went to Intel Fabrication Services and some other company. I'm forgetting about that. Who actually made the silicon? We designed it. Cool, awesome, but somebody else had to make it. So that still created, again, we had a good development in terms of designing, understanding technology, GG. It's just that manufacturing was still outside. So this was like we slowly chipping away at it. So at the some point in future, we were like, we got this, we got this. Because again, right now we have space program and a good space program. Like again, it only looks bad if you compare it to other far more advanced systems and compare it to every other country. It's like, heck, compare it to UK. Compare it to the great United Kingdom. It's like, bruh, this will be like, bitch, please. So, fundamentally, we do need needs. Like, we got this. You just need the brain for it. So there are three people who are making this. So we have Vikram Sarabhai Space Center, VSSC, this puppy basically. And these are the people who are familiar with space architectures. They know how to make satellites. They have been doing an amazing job of it. So they're like, okay, let's sit down, let's build something from scratch. So they are the architect, aka the chip designer who designed it. Like how you have iPhone designed in California, made in China. So same thing is designed in VSSC. So, okay, cool, awesome. But here is the same thing as Shakti processor. Even if you're designing the architecture yourself, you still have to go to someone else. But this time we did not. We have this puppy, Semiconductor Laboratory, SCL. SCL is a different branch, and this is responsible for all our weapons technology and critical silicon infrastructure. Meaning, if ISRO launches a satellite, who provides the sensor? So they are the one who is making the actual IC. So first time we are reaching a point where it's like, no, we can make a 32-bit microprocessor in Indian soil from start to finish. Not only the design is like made in India, the actual fabrication is also done in India. And they have enough experience with space-based technologies that they can do all the testing and validation for space. Like for example, normal chips has this weird issue where they outgas. Like the casing of the silicon outgasses, be it epoxy, be it plastic, they outgas. Now, is that an issue? Yes, especially in CubeSats where people found out the hard way that those gases can condense on your lenses and you're like, why the images are blurry? Oops. So, and again, sometimes worst case scenario has happened where because some gases are like conductive, it created an arc. So, Fundamentally, you do need someone who knows how space works, because again, whenever you look into space electronics and cost is ludicrously high, it's not high because of the technology that is going in there. It's high because of the testing, and they have experience in that. And ISRO is the customer, like somebody has to buy it. So ISRO is the customer, as in like for avionics system. We got the rocket, we need the brains for the rocket, so they are taking care of it. And the core idea is, over time, like brick by brick, day by day, we're going to reduce foreign dependency on intellectual property and chip dependency. Meaning we should not be like, oh, Taiwan is not giving you chips, no problem. China is not giving you, no problem. It should be like, I don't care. So that's the aim of it. These three players got together for it. So let's understand the core of it. So core is running on ADA programming language, this programming language. In strong typing, we trust. I have no idea what does that mean. Don't ask me about programming. It looks like black magic to me. But that's the whole idea behind it. It is a programming language that is utilized if you are making missiles, ICBMs, rockets, satellites, basically absolutely critical things where you cannot have oops. So these are generally used where you need oops-proof systems. And in-house ADA toolchain and integrated software development environment and simulators, all of them are being built in ISRO from scratch. So the idea is whole supply chain is like, no, we got this, we good, we got this. And not to mention, they are also working on creating a compiler for C language. But again, that's further down the pipeline. Right now, you have to be ADA expert in order to work on it. And they have 32-bit microprocessor with floating point support. Now, does that matter, floating point support? Yes, when you are talking about a linear number, it's cool, awesome when you are displaying it in binary. But when you are displaying as a floating, it becomes flexible. Meaning, same way when I talk about like 32-bit float audio file, it has no limit at 0 dB. Why? Because of this bit, which we call sign. It has positive and negative, meaning when it goes to 0, somebody figured out, it's like, hey, just convert that positive symbol to negative, meaning fold the data. So that's how you can shift audio in 32-bit file, even though it's clipped, even though it reached 0 dB, because you can shift the 0 by changing the plus to negative, basically shifting the line. So there is a sign system, and then you have Mentessa, the actual number, and then you have exponent. And whenever you are dealing with radar, it generally does not give you absolute data. It's not like this is 7 meters away. Nah. It's like 7 point and there will be a lot of noise. This sort of system is really good at handling that. And when you are making something that is dealing with something sensitive as navigation, you need something dealing with this on a hardware level. Like Silicon has to like, I got this, fam. Silicon cannot be like, can you processor, can you crunch it? No. Silicon is like, I got this. I understand these numbers. That's why you always hear, like, even on microcontrollers, like some microcontrollers do not have that and others do. And if they do, they will talk about this, like floating point support. It's a complex thing. Again, not if you're dealing with graphics card and all, those are like, bro, I do this in my sleep. But for microcontrollers, that's like good. That's good stuff. And how did ISRO came up to this idea? Well, there was an old structure known as from Sun Microsystems that was UltraSpec, as in like SPARC, SPARC. V8 was created, and this is made open source, so to say. As in like, it's not open source, as in like it's a standard. The standard is IEEE 1754. And this was used as a reference, meaning there are other silicons also India is making of 16-bit processors and some other processors. Those are utilizing that. So I'm reasonably sure this would be used as a reference guide, because again, you can do a lot in silicon. You don't want to. Like, why? Well, testing will destroy your life. So fundamental, because again, it's an exponent problem. You have 50 options. How can you combine 50 options? It's a limited number. What if you have 5,000 options? The combinations become exponentially larger. So testing becomes like, yeah, testing is taking years. So generally, you do not want to have something too bold. Like, you want to do systematically. It's like, let me put it this, let me test it, every combination of it, then go. Because again, these things are what we call oops proof. You cannot fire a missile of multi-billion-dollar and it's like, oops, that cannot happen. So generally, you want to have something very, very robust, very time tested. And I mean, not only in silicon level, but also the coding level. That's why ADA language is used. And what is the philosophy of the system? RISC system. It's basically like how you have PowerPC, how you have RISC-V, how you have ARM systems. Same philosophy, so to say, reduced instruction set. And floating point unit mathematics is coming from IEEE 754, this puppy. The sign, the Mentessa or significant, and exponent. These three things can be packaged into one unit. That unit is like floating point unit, and tada, you can deal with bonkers number, like bonkersly large number. So this is the core of it. So let's dive into the actual silicon, the Vikram 3201. This is 32-bit microcontroller, which is specifically built for 3.3 volt. ISRO's most systems are working at 3.3 volt, so they went with 3.3 volt. And this is 100 megahertz operating frequency. I'm like, wait a minute, isn't that slower than ESP32? Yes. Isn't that very slow? No. For space? No. You generally, and again, the same problem happens. The faster you make everything, the more likely there is to like have some unknown collaboration. Heck, like for example, when epic CPUs started to become really ludicrous, like 96 cores and 70 cores, they created a scenario where because of the switching, the clocks were so synced, everybody worked their ass off to sync the clock, it started to emit like a radio tower. Like a server started to emit like a radio tower. Why? Because all the bits were flipping at the same time. They had to introduce clock jitter just so that a megawatt farm does not become a megawatt radio tower. And again, not that kind of one, but again, it did break EMC compliance, which again, nobody thought, like, because if you're testing generally one thing, how would anybody know? And once you put hundreds of them, it's like, wait a minute, why all of them are screaming? So same thing happened. So generally, whenever you're talking about something space or something missile or something proof, where it's like, no, I sent it, it went. In those sort of scenarios, you generally do not want bonkers high speed. Again, it would be cool to have, but it's not a bad deal to like only be at 50 megahertz or even 100. And operating range, now this is where it shines, minus 55 degrees Celsius to 125 degrees Celsius. Now why is that? Well, imagine this puppy in a CubeSat, the targeted point, and it goes to the sun. Sun will like, let me put some love into you. It will cook up. It will go up to hundreds of degrees Celsius, 105, 106 easy. And then let's go, it goes to the winter side, as in shadow of the earth. It will start to radiate heat away, and tada, it will start to drop in temperature. It can easily get to minus 40. Now here's the deal. If you have electricity running into it, it will not go so low in the temperature simply because, again, vacuum is a perfect insulator. So lower end does not need to be like minus 100 or like absolute zero, as long as you have power. If you do not have power, then you have issue. But if you have power, you do not have to worry about, because again, they generate enough self-heat that it's not that big of a deal, as long as you have electrical power. And number of instruction is 152. Now, like, wait a minute, what does this mean? Simply think in this way. When you dive deep into a silicon, what exactly is a switch? Okay, switch means nothing. What above it? Above it, you have gates. You have AND gate, OR gate, this gate or that gate. You have all those gates. Now, here's the deal. How do you arrange them? You arrange them to make some instruction, hardware level instruction. So there is a list of these instructions, and every processor has that. Like if you look into ESP32 S3, it also has like, I think 600, 500 to 600 instructions. And what are these instructions? These instructions are what your compiler uses to do something. So these instructions would be fetch memory, dump data to memory, interrupt, write this, override this, like, those sort of core instruction. Your compiler knows this. So this is 152, and this is the whole point. You do not want this to be large number. Even if you can make large number, you do not want this, because you have to test every possible combination. So when you send this puppy to Mars, it actually works. And this was made into 180 nanometer. Like, isn't that ancient technology? That's exactly what is on Mars. Heck, if I'm not mistaken, Mars has 200 nanometer. So why is that? Well, when you are outside of Earth's magnetoshield or outside Earth's atmosphere, ion environment becomes naughty, meaning you have a lot of ions going, phew, 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 charged particles going, phew. Now, if you are talking about a giant gate, 180 nanometer gate, and a tiny ion went, shwing, it will not do anything. But if it's a tiny gate, like 4 nanometer, 5 nanometer, the gate is tiny. Charge particle going by, just by its magnetic field, it will flip the gate. So you will have bit errors on a processor level. So that's an issue. We generally, if you want something to be robust in space, generally it's advisable to not have very small gates. Like, even if you can make it, it's like, no. So 180 nanometer, 200 nanometer, 220 nanometers, they are still actively in use in ICBMs, basically anything that goes outside of Earth's atmosphere for safety and long-term reliability. And then you have to hermetically seal these puppies, because again, without hermetically sealing it, these puppies fart a lot. So you have to seal that. And it has low voltage reset. If you download its PDF, you will find LVR written on it. Low voltage reset is because these things generally deal with battery and solar panel. So there will be a time battery will be kaput. No matter what, it will happen. It's just, could it happen in 4 years? Could it happen in 15 years? Could it happen in 10 years? It will happen. So at that point in time, it will reach a point where it's like, oh, solar panel sees the sun, GG energy, it goes into shade, no energy. So in those sort of points, when is the voltage is slowly falling, it will reach into floating state, unwise, unknown. You do not want your space processor to behave like that. So generally, hardware level, you have what we call LVR. LVR is like detects it and puts the whole system. The idea is if you're going into the shade, it will shut down simply because it will not have rising voltage to restart again. But if it gets the voltage, it will wake up on LAN kind of command. It will boot up on itself. It will basically not operate if it's unstable. It works or it does not work. It will not be like blah, 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 blah. It won't do that. And again, you have a lot of interrupt lines, reset, processor clock, real-time counter clock, and wait selection and handshake signal for 1553B. Basically, if you what will you find in terms of sensor communicator, like how we have for cars and all that I squared C bus, I cube square bus is also there, I squared C, SDL lines and all that jazz. How does hardware of this caliber work? Well, you generally have military system 1553B. It became a USB of the high reliability kind of development. So a lot of command system is there, watchdog timer for interrupt, real-time counter. These things basically make the what you call nervous system of a rocket tick or nervous system of a satellite tick. This will not be the main processor, but this will make sure everything else works. So this is Vikram 3201. We already had a 16-bit one. This is 32-bit one and fully made in India. Now, India does have a bit of a paradox. While India has bonkersly large amount of talent, if you need proof, look into your top company's CEO. We don't have bonkers amount of talent. Like there is no discussion about it. We got talent. It's just that we have been making very slow progress post 2000. Like India was boomed when East India Company left us. We were boomed, like shift deleted kind of boomed, like really badly boomed. But we worked our ass off and solved all of the problems, brick by brick, day by day, and things worked. But here's the after 2000, something bad happened. Like we got to a point, everything like we were starving to like we got this, we got this. After that, we slowed. It's like it was not growing as it should have. Why is that? Well, because we are not capitalistic society. Like, isn't India is capitalist? Yes, it is, but it's certain aspect of our governance and certain core um, services of the country is not capitalistic. Meaning what we have is called socialist mixed economy, meaning government is doing things rather than government regulating things, government is doing things. So we have a lot of what we call state monopoly. And if you're like, wait a minute, that's a bad word. Yeah, that's a bad word. That's how Venezuela got kapoted. That's how, Iran ran out of water. Bad things happen when that happens. Or Pakistan became a beggar. So how the heck India has that? Well, we have that. That's the whole thing. We did enough of freedom so political private enterprise can happen. And again, thankfully, we have food. But not enough. Like a lot of core systems never privatized, so to say. So we have what we classify as mixed economy. So now, governments have zero accountability. Like if you ever read history, that's the first thing you will understand. Governments have no accountability. Like for example, German government agent can like, what if I put hydrogen bullshit? What if I build this hydrogen train and it just goes? And then he runs for 2 years and it's like, yo, it's bankrupting the country. Let's shut it down. Would that agent lose job? Be it MP, be it bureaucrat, whatever. Would it lose job? Short answer, no. There is no accountability in any government structure, nothing. That's why you never want them to build things. So they do not have accountability, meaning they rarely lose job, pension or anything. There is no consequence basically. Basically, if you do something bad, police will come to your house and annul you. But what if police does something bad? Good luck. Good luck in India. Like even if there is a video proof, nothing will happen. The maximum you will get is like suspended. I'm not even joking, like bad things, like really messed up things done by a police agents and all that, and it's just like suspended. Basically, a railway employee, literally he was busy on his smartphone and when he was handling a local train, put a bag on the accelerator, kaputted the local train, suspended. If he did that something similar in an aeroplane, he would never be allowed to fly again. So fundamentally, there is no accountability. And India, unfortunately, in its lack of wisdom or lack of maturity, put these sort of people in charge of almost everything important. DRDO, our brain department, basically it's our DARPA. ISRO, Indian Space Research Organization. BSN, Bharat Sanchar Nigam Nigam, basically it's our landline. We call it funnily, Bhai Saab nahi lagega. Meaning, bro, don't even try. It won't pick up a call. And you HAL, as in like Hindustan Aeronautical Limited, supposed to build jets for us. They have been trolling for 30 years. Because you have to fundamentally understand. This is one thing that is painful, but also necessary to understand. Without consequences or competition, there won't be any growth. All you will have is self-congratulation. So India is like, we did this. It's like, bro, we should have been doing this. Like this 32-bit, this should have been done by 2016. Like, and again, we had the money. We poured the money. We started on this. It's just like, taking the time. Why they're taking time? Because there is no penalty. It's like, oh, I'm not joking. A lot of people gave me a lot of hate into that ISRO's video. I was talking about Navik. And here's the thing. I did not make those videos. I did not talk about the data which I made. I literally read the report from inspector office of government accountability. Every nations have that, so good nations. So the idea with accountability office is like government send the money, what happened to the money. Accountability office is the one that will give the answer to the public, as in like what the hell happened with that money. So they are like ISRO just trolled it like 10 years behind schedule. They did not, like, they took the money for software upgrade, they just did not do it. They took money and just ordered wrong modem, like a lot of things where it's like, how the heck nobody is fired for that? Because here's the things like that happen. Sometimes it's an honest mistake, but if you have like a whole list, that list was published in 2018, where it's like so many messed up things, why the heck nobody was fired? No accountability. There is no competition. And growth does not. All you get is self. Oh, we did this. It's like the only way we can orgasm ourselves is like, hey, we are better than Pakistan. It's like, that's a really low bar to compete against. Like a really, really low bar to compete against. Like, that's not even a bar. That's like just sitting down on the ground. So fundamentally, like for example, many times people say, oh, this is a US Army built this or an Air Force built. No, Lockheed Martin built this. As in US CIA, I think, was like, yo, my man, U2 can be boomed now. Give me something that is faster than U2 and higher than U2. Now, I don't think it meets the higher criteria, but did meet the faster criteria. And no missile ever managed to catch it, even though it was faster than, like there were many missiles faster than this or disclosed piece of Mark 3.2. The closest missile got to it was like 1 kilometer. Radar data is there. So how that it happened? Because there were multiple companies, because there was competition, because there were consequences. If they did not deliver, the contract would be taken away from them and given to someone else. Heck, they could go bankrupt from this. Like CEOs can become just broke. And yes, it does happen. Heck, you can look into Intel. Intel CEOs are being changed. Like company is not performing, you go kaput. But when you look into DRDO, ISRO, BSNL, HAL, like I'm not even joking. I do have access because I'm my engine contacts. The engine is literally 30 years behind schedule. I'm like, bro, throw away the design. It's already outdated. If you started the design in 30 years ago, things have changed. 30 years ago, we did not have good computers. It's like 30 years, man. So fundamentally, it's just, that's the core point. Basically, we are so scared of this consequence and competition. And again, that's why India does not have Intel, IBM, AMD. Like again, government did not have to build it. They just have to navigate it. And they messed up with this Motorola. That's why China exists. And like in the same time frame, efficient computers came into the scene. Now, again, I do not know whether they will succeed or not. That's an unknown. But what they're trying, they're going all out. They're like, hey, why stay with RISC or CISC? What if you created a new architecture? I'm like, damn. I'm not talking like, this is how you rearrange it. No, completely different. They're like, yeah, we did it. It could succeed. It could not succeed, but they had the balls to do it and they got it very quickly. And I can easily see that like one day they will slowly either come close to bankruptcy and some Lockheed Martin or one of those weapons company is like, come bro, low latency processor, missiles love that. We want hypersonic hulululu. So fundamentally, that's the paradox with like India has talent. Like you would be shocked how many Indians are there in SpaceX building these things. Shocked, not even joking. So we got the talent. Talent is good, sorted. But you have to have competition and consequences. Government does not have that. Government's job is to regulate, not to build. If government has to start building things, they'll be like, So that's what's limiting us. That's why these sort of small, successes, that's all we got so far. Even though we could have been flying so far, so ahead. It's just like, So this was my presentation on basically Vikram's 32-bit microcontroller or microprocessor. Hopefully you have liked it, learned from it. In that case, please click the like button, share it among your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.